Okay, we'll start. Okay, so good evening guys. So till now we are focusing on laws of motion, right? So yesterday we have seen some free body diagrams of the objects. So now we will see what is the equilibrium condition and we'll look the problems, okay, like how the acceleration will takes place, and if I pull the block, and if each block will be having what is the acceleration, okay, that one we'll see. So up to which slide we have completed up yesterday? So this is the problem. Last we have seen this problem, no? So bullet of mass 0.04 kg moving with a speed of 90 meter per second enters a heavy wooden block and it stopped after a distance of 60 centimeter. What is the average resistive force exerted by the block on the bullet? Right now. So once again we'll see the problem. So mass is 0.4 kg. Yes, so mass is 0.4 kg and moving with velocity it is 90 meter per second. So it enters a wooden block which is of, has been stopped, no? So 60 centimeter, no? So S will be equals to 60 centimeter. If I convert it will be 60 into 10 power minus 2 meter. So which is nothing but 0.6 meter. Then stopped in the sense final velocity will be equals to 0. So what is the average resistive force? So what is the formula for force? We know force equals to mass into acceleration. We know the mass but we don't know the acceleration. I need to find the acceleration. That's the main motive of the question right now. So we know u, we know v, and we know s. So in the kinematic equation, which one I can use? V square minus u square equals to 2as, right? No. So from the kinematic equation, v square minus u square is equals to 2as, where v square, that is I can neglect it out because 0. So minus, it is 90, no, 90 square is equals to 2 times of acceleration into 0.6. That's it now. So now what I can do here? So minus 8100, no, minus 8100 by 2 into 0.6 will be equals to acceleration, right? No. So if I multiply by 10 by 10, it will become 8100 by 12 into 0 here. Yes, no, into 10. Okay. So 81000 by 12. So how will be my acceleration? So this one will be my 4 times and this is my 27, right? No, 27 only, no. So 2 times 6 and remaining 2 will be there, 21 7 times. So 2700 will be there, right? No. So this 1 times and this one will be my 135. So 27000 was there. Now 13500 will be there, right? No. So 13500 divided by 2 is equals to acceleration. I will take this acceleration as it is and substitute in the value of F is equals to ma. Okay. So do the calculation and you can get the value of force. That's the answer for this question. Okay. Can we go for the next one? So we have solved this question also in the last class, that is y is equals to ut plus half at square of gt square. So I need to find the force acting. So we got F is equals to mass into g, that is acceleration due to gravity. Okay. Now the next topic, it is impulse. Okay. So impulse, a large force acting for a short time to produce a finite charge in such change in momentum. So like force into time is nothing but impulse, which is denoted by the letter J. Okay. So what will be the SI unit of this one? Force we know. Force is Newton and time is seconds. So Newton seconds will be my SI unit of impulse, right? So what we can understand here, if time decreases, impulse also decreases. Time increases, impulse also increases. So why we have taken this example, you know, see, for example, a batsman is bowling a ball. I mean, a bowler is bowling a ball, right? No, yes, no, bowler is bowling a ball. So if a batsman is there, if he keeps a bat, okay, and if we take a bat little bit back, no, and if we hit the ball, a ball will go a longer distance, right? No, a time how much he is taking, that much impulse will be taken place, no, like change in momentum they are saying, no, yes, no. Done. So SI unit will be Newton second, right? No, force is Newton and time is seconds. Done, right? A batsman hits back a ball straight in the direction of the bowler without changing its initial speed of 12 meter per second. If the mass of the ball is 0.15 kg, determine the impulse imparted to the ball. So we know that formula for the impulse. What is the impulse formula? We know force into time, right? So J is equals to F into T, right? No. So what is force here? Mass into acceleration into time, the time I have taken. So what is acceleration here? Velocity by time into time. So time will get cancelled off, no. So what will happen here? Mass into velocity. One more thing what we have learned here, a large force acting for a short time to produce a finite change in momentum. What? Change in momentum, no. So change in momentum is nothing but impulse, right? No. So what I should do here, they are saying that a ball has been coming with a speed of 12 meter per second and it's like a batsman hitting in the straight direction, right? No. So ball is coming with 12 meter per second, again he is hitting in the straight opposite direction. So again it will be 12 meter per second, right? No. Batsman hits back a ball straight in the direction of the bowler without changing its initial velocity, right? No. So initially velocity was 12 meter per second. After hitting also it is 12 meter per second. So if the mass of the ball is 0.15 kg, determine the impulse imparted to the ball. So change in momentum I need to get it, right? No. Take this question. So final velocity minus initial velocity, no. So final velocity minus initial velocity in the sense, like I will explain here. So I will take a case here. This is the question. Two identical billiards balls strikes a rigid wall with the same speed but a different angle. Okay, here is the question. Direction of the force on the wall due to each ball, like first initially it is going, again it will hit back and coming, it's the same velocity. Second case what I am taking is with the angle. For the first case, see, initial momentum will be mass into velocity, right? No. Final will be minus mu in the opposite direction. No, velocity should consider the direction, right? No. So a change in momentum will be final minus initial, no. So final what it is? Minus mu. Initial minus of plus mu, no. So minus 2 mu. Got it? That's why I told you to take that question and we will see that slide. You can take this topic and we will go for that question, okay? So first part of the question is this diagram, okay, it's in a straight manner. Second part of the question is making angle theta, that is angle theta is nothing but 30 degree. Okay, so what we will do in this case, we will take the components, no, what we will do, so let me take this is my x axis and this is my y axis, no, so component in the sense this is my u cos 30 degree, so this is my again u cos 30 degree, so this is my u sin 30 degree, u sin 30 degree, right, no. So in the y component both will get cancel each other, only the x component I will add it, okay. See, so the first case, initial velocity in x direction will be mu, initial momentum in x direction will be mu, final momentum will be minus mu. So going in positive x axis, in negative x axis. So in y axis what happens, momentum 0. So there is no momentum in y direction, no. So impulse is the change in momentum vector, no. So which is nothing but minus 2 mu. So now what will be the answer for this question? So minus 2 mu will be the answer, no. So what I can do here, going with velocity 12 meter per second, mass 0.15 kg and a change in momentum, no, so 2 times. So answer will be, give the answer for this. 0.15 into 12 into 2, 3.6. Do it fast, do it, man. Okay. So 3.6, no, right, no. Okay. So impulse and force are in the same direction. The force on the ball by the wall is normal to the wall along the negative x direction. So using Newton's third law of motion, the force on the wall by the ball is normal to the wall. Okay. So now the next part is coming. Here what I told, I should take the component, no. So component in the sense the angle which is closer to the axis will be my cos theta, away from the axis will be my sin theta. So mu cos theta positive minus mu cos theta for the final case. So what will be my answer? Minus 2 mu cos 30 degree will be my impulse, right? No. What about this case, y direction? So y direction, what I will see here is, this is my component, no, so going in this direction. So for y direction, for this one will be towards down, for this one it's going in this direction, and for this also it will be in the same direction. So both are negative direction, no. So minus mu sin 30 minus mu sin 30. So what will happen in the y direction? Final minus initial, no. So final, what is final here? Minus mu sin 30 degree minus of minus, no. So minus of minus mu sin 30 degree, which will be this one, this will get cancelled. So in that y direction there will be no impulse, right? No. So y component of impulse will be 0, but whereas x component the impulse is minus 2 mu cos 30 degree, right? No. So the same question, here it's coming with the velocity 12 meter per second and ball is having a mass of 0.15 kg. Now it's coming with some angle, that is 30 degree. So can you give answer for this question now? So what I should do? The simple thing, 2u m cos 30, no. So we got the value of 2 mu. Only thing is cos 30. So cos 30 is 1 by 2. So multiply by 1 by 2, that's it. Answer is 1.8. Done? Okay. So next topic is Newton's third law of motion. So to every action there will be equal and opposite reaction. Right now, so if I apply a force x force 10 Newton in x direction or in this direction I am applying. So what will be the opposite force? Minus 10 Newton. So if I apply some force in this wall, no, for example 10 Newton force, equal and opposite force should be there, no, which means in the opposite direction minus 10 Newton will be there, right? No. So if I throw a ball, it will return back to me, right? No. So whatever things we do in a life, it will return back to us in the future. Yes, no, that's what we'll say, a karma, no, right? No. Okay, so it's applicable in life also, right? Right. So a force on A by B is nothing but force of AB will be equals to minus of BA, like it will be in the negative sign, that's it. Take it. Good evening, good evening. Done? Done. So the next one is equilibrium of a particle. Okay. So net external force on a particle is 0 when a particle is at rest or uniform motion. So what is the first law says? Newton's first law. When a body is at rest or in motion, unless or until an external forces act on them or applied on them. Right now. So suppose a body is at rest. Right now, if a body is at rest, whatever the gravitational force is acting, the normal force will be acting in opposite direction, right now, which is nothing but a weight and the normal force. So the same thing, if a body is to be in rest, no, a force in x direction will be equal to minus x direction. A force in y direction should be equal to minus y direction. That's the thing we should, that's the thing Newton's first law says. So if I take a object M, a force F1 is acting, equal and opposite force should be there to keep a body at rest, right now. So F1 should be equals to minus F2, no. If I am applying a force F1, opposite force should be F2 is there. So which means F1 will be equals to minus F2. So if I take F1 plus F2 will be equals to 0. So which means object is at rest, right now. So this is for the one direction. For if I take in a space or if I consider any 3 or 4 forces, the same thing will be there. So F1 plus F2 plus F3 or F4, F5 up to Fn, whatever it is, the sum of force will be equals to 0 on the particular object. Take it down first. So the thing we can understand here is, if object is moving, I can say that sum of force of the object will be equals to mass into acceleration. So suppose if I consider the same object, this object is there, three forces are there. What will happen if object is moving? A sum of force I will consider. So F1 plus F2 plus F3. Okay, if the object is moving, in the sense, what is the force formula? Mass and acceleration, net acceleration, no? Right, no. So the total force I am adding and I am keeping is like will be equals to mass into acceleration. So if object is not moving, it is at rest, means acceleration will be 0. So acceleration 0 means this right hand side will become 0. So the sum of force will be equals to 0, right? So now we will look into the problems, okay? Completed? Okay. So the first problem. The upward normal force exerted by the floor on a elevator passenger of a mass 60 kg is 550 Newton, so 570 Newton. The acceleration of the elevator is, what they are saying, upward normal force. Okay. Suppose let me consider there is an elevator and a man is standing inside there. Okay, what they are saying, a passenger or a man's weight is 60 kg, right? No, so what they are saying is the upward force, which is 570 Newton, it will be in this direction, 570 Newton. So what will be the weight? Weight is nothing but mass into gravity. So what is the mass here? 60, no? And gravity I will take approximately 10. Okay, 9.8 is the proper value. For the calculation purpose we will take 10 meter per second square. So 10. So what will be the answer? 600, right? No, 600 I will get. So if I see weight will be acting towards down, which means 600. So now if I take these two, one force is upward, one force is downward, 570 and 600. In which direction object will move now? A direction where the force is more. 570, 600, which is more? 600. So in the direction of 600 object will move, right? So let me consider this is the direction of acceleration, right? No, what I told, whenever we are solving this kind of problem, we should consider the force positive in the direction of acceleration, negative in the opposite direction of acceleration, right? No, so what is the direction of acceleration? Towards down. What are the forces are available towards down? 600. So 600, opposite direction is 570 minus 570. Object is moving or stable? Moving. So should be equals to, what is the mass? 60. I don't know the acceleration. A. So 600 minus 570, 30, divide by 60 will be equals to my acceleration. 0, 0 will get cancelled off. So 1 times and this 2 times. So acceleration will be 1 by 2 meter per second square. Is it moving upward or downward? Downward. That's it. So which is the correct option here? Third option will be my answer. No, it's option 3. Okay. Can we go for the next question? Okay. So the next question is, two forces are such that their sum of their magnitude is 18 Newton. So two forces are there. Let me consider the forces F1 and F2. What is the first condition they are saying? Sum of their magnitude. No, sum of their magnitude means F1 plus F2 should be equals to 18. Fine. That's the first condition. F1 plus F2 will be equals to 18. Then their resultant is perpendicular to the smaller force. I don't know which is smaller force, no, they have not mentioned. They told me that F1 and F2 will be equals to 18 and resultant will be perpendicular to the smaller force. So whatever, like, can I consider F1 as a smaller force also? F2 is also a smaller force. It's my wish to consider right now. So what I'll do, so let me take, this is my resultant. No, perpendicular they are saying, no, perpendicular means angle between both the vectors should be 90 degree. So 90 degree. So F1 I will consider, right now, F1 in this direction, F2. What is the method to add the vectors? First vector, second vector should be head of the first vector, no? So resultant vector will be starting from tail of the first vector and end of the last vector. So this is my second vector F2 and this is my resultant vector R. This is the diagram. Now what they are saying is magnitude of the resultant is 12. F1 plus F2 is 18. Second one they have given the condition perpendicular. Third one R is equals to 12. Then magnitude of the forces are, they are asking either it is 12.6, 13.5, 10.8 or 16.2. Okay. So what I can use here, it's a Pythagoras theorem. So what is the Pythagoras theorem for this case? R square plus F1 square is equals to F2 square, no? Right, no? So we know that F1 plus F2 as 18 and R as 12. I'll substitute the values now. Okay, I'll substitute the values. What I'll do is I'll keep R one side and remaining other side. What will be the answer? F2 square minus F1 square. One condition we know that A square minus B square is nothing but A minus B into A plus B. Right, no? R square is 12. So 12 square is 144. So 144 is equals to F2 minus F1 into F2 plus F1. What is F2 plus F1? 18. So 144 is equals to F2 minus F1 of 18. Right, no? So from this F2 minus F1 is equals to 144 by 18. So this is my equation 1 and this is my equation 2. If I add both the equation, now what will happen? F1 and F1 will get cancelled off. 2F2 will be equals to 18 plus 144 by 18. So what is 144 by 18? It is 8 times, no? So 1 times and this is 8 times, right? No. So what will happen is F2 plus F1 is equals to 18. This is 8. It is equation 1. I'll write here. This is 8, no? I'm adding both the equation. What will happen here? F1 will get cancelled off. 2F2 will be equals to 26, no? 26. What about F2? F2 will be 13. So if F2 is 13, what about F1? 5. So which of the correct option here? 13 and 5. Option 2. Done? We'll go for the next question. Okay, so the next question is, if the tension in the cable of 1000 kg elevator is 1000 kg, okay, elevator is 1000 kg weight, the elevator is accelerating upward, downward, maybe at rest, accelerating, maybe at rest or uniform motion. What is the thing? Fourth option. That's it. It is Newton and this is Newton. Okay, tension and weight, no, so Newton, and elevator is 1000 Newton, 1000 Newton. Okay, so what is the thing now? Maybe at rest or in uniform motion, right? No, because if I see here, tension is 1000, weight is also 1000. So tension will be, if an object is there, no, if object is there in, it's hanging like this, so tension will be away from the object. So weight will be towards down. So both are in opposite direction, no, both the forces. Yes, no. So one is 1000, another one is also 1000, which means both are having same weight, of same forces, right? No, same forces, which means will be in rest. Yes, fourth option. Acceleration is 0 obviously, so uniform motion will be there, right? No, we have studied the condition, no, uniform motion. So when, what is the uniform motion condition? When acceleration is 0, that's it. So that's why maybe rest are in uniform motion. Okay, option 4. Done. So the next one, if 3 equal masses of 1 kg as shown in the figure are accelerated with an acceleration 2 meter per second, then what is the tension 2? So this is tension 1, this is tension 2. Why they have taken tension 1 and 2? Because both are different ropes. Okay. So what I should do? I should draw the free body diagram first of all, right now. So let me take the free body diagram now for the first case. So what they have given, it is applying some force. Okay. So what they have given here, first one, 1 kg, no, force is acting in this direction. So tension will be opposite direction. So this is my tension, T1, right now. So this is force accelerating, how much? 2 meter per second square. Yes, no, 2 meter per second square. I need to find tension T2. So I need to first find T1 also, T2 also separately, then only I can know. Yeah. Which one? Answer is 4 Newton. Oh, we'll see. You got 4 Newton. Or 2 Newton. You should say the proper answer, no? 2 Newton, 4 Newton or option 2? First option. Okay, we'll see. You lock and keep. Okay. Now, what is the second free body diagram? Again, 1 kg, tension T1, and this is tension T2. Object in the same direction, 2 meter per second. For the third one, again 1 kg, T2 will be there. That's it. Now, can I write the equation? Forces positive in the direction of acceleration, negative in the opposite direction of acceleration. So, F minus T1 will be equals to, mass is 1 kg, so 1 into 2 will be 2. So mass 1 kg, acceleration 2. So this one, T1 minus T2 will be equals to 1 into 2. Again T2 will be equals to 1 into 2. So if I add everything, what will happen? T2 will cancel, T1 and T1 will get cancelled off. So F will be equals to 2 plus 2 plus 2, which is nothing but 6. So force is 6 Newton. Right? No. Now I need to find the tension T2 they are asking. So T2, directly I can say it is 2. Without solving also I can say no. Yes, it is direct question only, 2 Newton. We'll go for the next question. Can we see the next question? So the next question is, in the arrangement shown in the given figure below, the strings are in light and inextensible. The surface over which blocks are placed is smooth. What is the acceleration of each block? We have did similar question no last time. Can we see now? So what is the thing? Force will be equals to, acceleration will be equals to force by sum of mass. No, what is sum of mass? m1 plus m2 plus m3. This is the direct thing. No, so what is the force? 28. So 28 by what is the masses? 4 plus 2 plus 1. So 28 by 7 will be 4 meter per second square. Option 2. Right? Can we see the next question? The three blocks are placed as shown in the figure. Mass A, B, C are m1, m2, m3 respectively. The force exerted by block C on B. Block C on B. So what I should do? I should find what is the force in between them. No, I need to find the force in between the block C and B. So can I draw the free body diagram first? So if I draw the free body diagram, first one I will take the mass C, block C, which is mass m3. No. Yes, normal force. Obviously the contact is there, normal force only will be there. No. So what will happen? 1 will be my weight towards down, m3 g. 1 will be my normal force due to surface, n1 or n3 I will take. Okay, from down we are going. No, so n3 I will take. One more normal force will be there. No, which is by block B towards down. So n2. I have taken the block, due to the surface one normal force, due to this block one normal force, the weight will be towards down. Now if I go for block B, m2g is there, right? No, m2g is there, and n2 will be towards up, right? No, what about one more normal force towards down? No, n1 because of A. What about A? Only one normal force will be there, one weight will be there, m1g n1. That's it. No. Now can I write the equations? Is object is moving? No, it is at rest, which means upward force will be equal to downward force. That's it. No. So can I write like this? n3 will be equals to n2 plus m3g. For this, n2 will be equals to m2g plus n1. For this one, n1 will be equals to m1g. What is the thing they are asking? B they are asking. So in between, B and C they are asking. What is the normal force in between them? N3. So I need to find N3. So N3 in the sense, this is the equation I need to get it, right? No. So M2G plus N1. What is N1? M1G. So M2G plus M1G. What is N2 now? M1G plus M2G plus M3G will be my N3. So M1 plus M2 plus M3 of G. This is my thing. Is it correct? This is the thing you told, no? But what is not N3? N3 is by surface, no? I need to find N2 only, no? N2 by block B. Again N2 by block C. So option will be M2 plus M1 of G. Block B on, so block C on B, no. Block C on B in the sense, this one, no. In between them I need to find, no. In between them in the sense, this is the thing, no. N2 and N2 only, no. N1 will be my A. So answer will be, that's it. Okay. So read the question properly, okay. So it's not N3, it is N2 only. So option 2 is the answer. We'll see next question. So here is the question. 3 blocks of mass M1 is equals to 4 kg. So this is my M1, guys. Okay, M1, I'll write it here. So M1 and this is my M2 and this is my M3. So M1 is equals to 4 kg, M2 is equals to 2 kg and M3 is equals to 4 kg. Are connected with ideal string passing over a smooth massless pulley as given in the figure. The acceleration of the blocks will be, okay. Now if I consider here 2 kg and 4 kg, one more side it is 4 kg. So total 6 kg, 2 kg, so 4 kg. In which direction object will move? Towards like this, no? So if it's going like this, acceleration for this will be towards down. If it is going like this, acceleration for this one will be towards up. So the free body diagram will be looking like this, no? This is my pulley, this is my mass M3 and this is my M2 and this is my M1. It will be going like this, no? Correct only, no? My acceleration direction. So acceleration is in this direction. Correct only, no? So what will happen? I need to take the free body diagram first. So free body diagram means this is one string and this is one more string. So two strings are there. So two tensions will be there. Okay. So what is the equation I can write here? M1 will be there. This is M1G. Tension will be upward. Right? No, away from the body for M1. So T1 I will take. So towards down object is going. Right? No. So this is for M1. For M2. So if I see M2, two tensions are acting, no? So two tension in the sense, one tension towards down, that is T1. One more tension towards up, that is T2. One more force is there, that is weight, no, for block 2. That is also towards down. M2G. What about M3 now? M3 will be, so this is also going down. So M3, tension is towards up T2, M3G will be towards down. And object is going up. Now equations I need to write. So forces acting towards acceleration positive, away from the opposite direction of acceleration negative. So for this T2 minus M3G will be equals to M3A, one equation. For this T1 plus M2G, no? T1, this is equation 1, T1 plus M2G minus T2 is equals to M2A, equation 2. For this one, it is M1G minus T1 will be equals to M1A, equation 3. So I got 3 equations. So from this 3 equation I need to find the acceleration, that's it. Okay. Take this. So give me answer in. So if I add, what will happen? Everything. If I add everything, what will happen? T2, T2 cancel. T1, T1 cancel. So what is the remaining thing here? M1G plus M2G minus M3G will be equals to M1 plus M2 plus M3 of A. So here M1 it is 4, M2 2, M3 4. So can I cancel this one? M1 it is 4, no. It is also 4, no. So 4 into 10 40, 4 into 10 40, plus 40 minus 40 cancelled off. Remaining will be 20 divided by the total mass, how much? 4 plus 4 8, 8 plus 2 10, 10 divided by A. So A will be 2 meter per second square. That's the answer. Okay. So with this we'll end the session. Okay, we'll see some more question in the next classes. Bye guys, we'll meet in the next class.